Hi everyone, I'm Jackie, and today I'm going to go over the August 2024 SAT predictions. Okay, so first things first, this type of question is on every type of an exam, SAT exam, so it's rearranging equations. Okay, so let's look at one that recently appeared, a similar variation. So here I have 1 divided by 5x y plus xyz is equal to 1 over 4yz. And I'm asked to put everything in terms of y. Okay, so not a problem. My first step would be to make xyz, the left side of the equation, to have the same common denominator. So to do that, I'm going to make this 5xy, and I'm going to multiply this all by 5xy. So then this would give me 1 plus 5 x squared y squared z all over 5xy, and that's equal to 1 over 4yz. Okay, next up, well, we can cross multiply. So I would have 4yz, 1 plus 5x squared, y squared z, and that's all equal to 5xy. Okay, next, since I'm looking to solve in terms of y, I can divide each side here by y to simplify it a bit further. Then I can distribute, so then I would have 4z, this, so I'm going to here and now here. This would become, so 20x squared y squared z squared equals 5x. Okay, so now I'm going to move the z to the other side of the equation. So that would be 20x squared y squared z squared is equal to 5x minus 4z. And remember, I want everything in terms of y. So now what I can do is divide each side by 20x squared z squared. And then in doing so, this will cancel all these. And then this would also be 20x squared z squared. And this is all in terms of y squared, right? So let me just move that final step over here. I have y squared is equal to 5x minus 4z divided by 20x squared z squared. And then final step, just take the square root to get everything in terms of y. So y would be equal to the square root of 4x minus 4z divided by 20x squared z squared. And that looks precisely like option B. Wasn't that a good one? So these ones, they frequently come up on the exam, just to look at another one to, you know, help you solve these ones. So here I'm given the equation r is equal to f over n plus f. And this, we can read it, but if I look at the answer choices, everything is in terms of f. So I know that I need to rearrange in terms of f. So let's do that. So I can first multiply each side by n plus f, which would give me Rn plus Rf is equal to f. So then since I'm solving in terms of f, I want to put group like terms together. So Rf and f I could move together. So I can make this Rn equals f minus Rf. And then since I have a common term f, I can factor it out. So this would be Rn is equal to f 1 minus r. Everyone sees that. This would become f, this is fr, or rf. And then final step, I just need to divide by 1 minus r. And we can see this would cancel. And I'm left with Rn divided by 1 minus r is equal to f. And that would be the amazing answer choice B. Okay, so just make sure you feel comfortable with rearranging equations for the August SAT. I feel pretty strongly one of those ones will appear on the exam. Next up, we have percents. Okay, so percents, they might seem easy, but just be aware of the following concepts that I'm about to provide insight into. So here, Hongbo sold X cell phones in 2013. The number of cell phones he sold in 2014 was 128% greater than in 2013. And the number of cell phones he sold in 2015 was 29% greater than in 2014. Which of the following expressions represents the number of cell phones Hongbo sold in 2015? Okay, so I mean, this is just testing percent increases in this case. So let's say the number of cell phones he sold in 2014 was 120% greater than 2013. Okay, so then if I wanted to calculate this, important, I would do 1 plus, we would say k percent, or 1 plus 1.28, which is equal to 2.28. So this would be like x multiplied by 2.28. And then here, and the number of cell phones he sold in 2015 was 29% greater than in 2014. Okay, so if it's 29% greater, this too, I would just do 1 plus k percent. This would be 1 plus 0.29, which is 1.29. So I would just multiply that by 1.29. And that would just be the answer, which looks just like option D. So be really careful, especially with the 128%, because the trap answer definitely is option C. Make sure you add in that one. So just be hyper aware of that for the exam whenever you take it. And let's take a look at this one, an amazing one. So the value of R is 20 over 21 times the value of T, where T is greater than 0. The value of T is what percent greater than the value of R? Okay, so also if I wanted to get T, I would just multiply each side by 21, or the reciprocal, so it'd be 21 over 20 R is equal to T. So now that I've defined the terms, I can just do the percent increase formula. So remember, that would be like the new value minus original over original multiplied by 100 will tell me by what percent greater T is than the value of R. So in this case, basically, I would do like, oh, okay, so it's be T minus R over R times 100. Now I can just put the values in, substitute them. So it'd be 21 over 20 R minus R, which since R is actually equal to 21 over 20T, but I want everything in terms of R, I'll just put it in as R over R times 100. So this will result in 21R minus R would be 21 over 20R, just gonna find the common denominator of 20 over R times 100. And that would be, so 21 minus 20, 1 over 20 R divided by R times 100. So then here, I can cancel out the R's. And then basically, it would just be 1 over 20 times 100. That becomes 100 over 20, which is 5. So basically, it would be 5% greater than the value of R. And it tells you, like, for example, if your answer is 39%, enter 5. So I would just enter in 5 into my computer. Wasn't that a good one? Okay, so continuing our percent journey. Oh, this one. A rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what is the value of p? Okay, so normally a rectangle is just area equals length times width, right? But this one, so it says, these alterations decrease the area of the rectangle by 12%. So just like I did in that first problem where it was 1 minus or 1 plus k%, I'm going to do 1 minus. So this would be 1 minus 0.12, which is 0.88. So the new area of the rectangle, it's 88%. It had its length increased by 10%, so this would be 1 plus 0.1, which is 1.1. So 1.1 the length, and decreasing its width by p%. So the width would be like width 1 minus p%, whatever that may be, which we're going to solve for. And then I have to get what the value of p is. Okay, so let's see. First, I do have two equations. My original area of the rectangle, area equals length times width, and then the resulting rectangle. So first, what I can do is substitute in the LW here. Let's do that. So that would be 0.88 LW is equal to 1.1, oops, 1.1 L times W, 1 minus P over 100. Now let's go ahead and divide each side by LW. Why? Because I can cancel, then I'm only left with the variable P. So then I would have 0.88 is equal to 1.1 and then 1 minus P over 100. Okay, next I'm just going to divide each side by 1.1 to simplify further. So 0.88, just checking, 0.88 divided by 1.1, it's 0.8. Okay, so this would be 0.8 is equal to 1 minus P over 100. Remember, I'm solving for P. Next step, I can just subtract 1 from each side. So like negative 0.2 is equal to negative P over 100. Multiply each side by 100. So I get that, well, negative 20 equals negative P. I don't want a negative value, so I'll multiply each side by negative 1. And that will tell me that positive 20 is equal to P. And therefore, I would say that's the answer. Wasn't that so great and amazing? Okay, so moving on to vertex form. So vertex form, you should definitely know I'm talking about vertex of a parabola. And that formula, it's always y equals a x minus h squared plus k, where h and k stand for the center of the vertex. Okay, you need to know this formula, so make sure you have it known and memorized for the exam. So a simpler problem, then we'll look at more advanced problems, but you need to know this formula, y equals a x minus h squared plus k, because you might have to do a verbal interpretation of it. Like this one, a child throws a snowball. A quadratic model gives a predicted height above the ground h in the meters of the snowball in terms of the time t in seconds after it's shown. According to the model, the snowball is at a height of approximately 1 meter when thrown and reaches a maximum height of 2.8 meters in 0.6 seconds after being thrown. Which equation could represent this model? So first, maximum or minimum always indicates the vertex. So I therefore know that the vertex of this quadratic would be 0.6 and 2.8. So looking at the formula, this would have to be x minus 0.6 squared and then plus 2.8. So why is it minus? Because whatever's inside the square has an opposite sign of what the actual output is. So looking at this, I don't know specifically the value of A, but just knowing vertex form, it has to be answer choice A. And that's it. That's the answer. You see, it's just knowing your vertex form and you can get an easy question like this correct and not worry about losing any points. So moving on to more complicated ones. Okay, so this one, it's an SAT classic because this very question has been on previous exams, or very similar questions has been on previous SAT exams. And I'm talking about from like 2016, 2017. And it was recently repeated on the June SAT exam. And I think there's a high probability that it could come up again on August. Not this exact question, but a very, very similar one, just different numbers. So let's look at it. So this one, a quadratic function can be used to model the height in feet of an object above the ground in terms of time and seconds after the object was launched. According to the model, an object was launched into an air from a height of 0 feet. Okay, so the object was launched into the air from a height of 0 feet. That means that there is a starting point of 0, 0, and it reached its, oh, look at this language, maximum height. So vertex is at 25 feet, 1.25 seconds after it was launched. Based on this model, what was the height in feet of the object 1 second after it was launched? Okay, so this is a great one where we can use vertex form. So y equals ax minus h squared plus k. I'm given the vertex. Whenever I'm given the vertex, think to use vertex form. So my vertex, it's here, 1.25, 25. Those are my h and k values of the vertex. So I'm gonna go ahead and plug these in. So this would be x minus 1.25 squared plus 25. And then I want to get what a is. And since I have another pair of coordinates, I can easily do that. So I can substitute in my 0 for the y and also the same, the 0 for the x. And in doing so, I will solve for a. Okay, so let's go ahead and do that. For me, I'm going to solve without a calculator. So I'm just going to convert this into a fraction. So this would be minus 5/4. You can use a calculator. I just want to show everything how nice it does work if you don't use a calculator. So here, just remember when you square, go to top to bottom. And this would be, so 0 is equal to 25/16 a plus 25. I move that to the other side. So negative 25a over 16 is equal to 25. I now multiply each side by the reciprocal. So 16 over 25. Well, negative 16 over 25. And negative 16 over 25. So we can see this cancels really nicely. And I'm left with that a is equal to negative 16. Okay, so now I have a. Go back to the original quadratic. So it's just negative 16, x minus 1.25 squared. But remember, I'm making that into, well, wait, so x minus 1.25 squared plus 25. And then final step to do would just be to now find, based on the model, I have the model, what was the height in feet of the object 1 second after it was launched. So now we will just put this in for 1, or the x, and then solve for y. So y is equal to negative 16, 1 minus 1.25 squared plus 25. So this would be 1 is equal to negative 16. 1 minus 1.25 is 0.25. That is the same as negative 1/4 squared plus 125, just to show, square the top and the bottom. And I would get y equals negative 16 times 1 over 16 plus 25. This will cancel. So it's negative 1 plus 25, and y is equal to 24. And that is our answer. Wasn't that amazing? So just remember, if you are provided, if you see language in the problem, such as maximum, minimum, and you're provided the coordinates of the maximum minimum, aka vertex, think about using our handy dandy vertex form, because maybe it will be the key to getting the problem correct. Okay. So for those of you who enjoy these videos, I'll continue. I have a very similar problem that you guys can try now on your own based on the exercise we just did. Okay, so I'm just gonna put a timer here so that you can feel free to solve. And then we'll go over this in 1 minute. So just take a minute, try to work out this problem on your own, see if you get it. I'm excited to see. Okay, let's revise. So you see it's pretty much similar to the previous problem we just did. So first, vertex form. I know that the object was launched from a height of 0 feet. So again, we're at 0, 0, 0. And its maximum height was 16,000 10 seconds after it was launched. So it's 10, 1600 is my H and K vertex values. Okay, so just like before, so y is equal to a x minus 10 squared plus 1600. Then I will put in the other 0, 0 coordinates. So 0 is equal to a 0 minus 10 squared plus 1600. This will give me, well, okay, I'm so showing all the steps, 100a plus 1600. So negative 100a is equal to 1600. And then divide each side by negative 100. And we get that, oh my goodness, look at this. A, yet again, is negative 16. Okay, then, so go back, negative 16, x minus 10 squared plus 1600. And then I have to find, based on this model, what was the height in the feet of object 15 seconds after it was launched. So go ahead and put 15 in here. So y equals negative 16, 15 minus 10 squared plus 1600. So y is equal to negative 16. This will be 5 squared, so times 25 plus 1600. So negative 16 times 25 is equal to negative 400. Should have done that. Plus 1600. And that will give me correct answer of 1200. So after 15 seconds, the height will be at 1200 feet. Wasn't that so great and amazing? Okay, so no vertex form. Maybe be familiar with this problem. And if you want to see more problems of vertex form, I go over them. Well, they're in like the 5 most difficult SAT problems. There's a couple more vertex form type problems. But I could do a whole video on them if you guys want. Request below in the comments. Okay, so continuing our journey. And just one final instance, this is more of a translation problem than vertex form, but it is in vertex form, so you should be familiar with translations. Watch my other videos on that. But this one just to show, so remember it's in the xy plane, the graph of y equals x minus 6 squared plus 3 is the image of the graph of y equals x plus 5 squared plus 3 after translation, how many units to the right? Okay, so just imagine this visually to give a visual. Also, you could plug this in on Desmos, but I like to show things here visually. So here I know my H value, it's positive 6, 3 in the original parabola, and then the image here goes from negative 5 to positive 3. So here I'm like 1, 2, 3, 4, 5, 6, 1, 2, 3. So it's around here. And original. And then the other one, so 1, 2, 3, 4, 5, 3. Okay, so like I'm trying to find the distance between here to here. And it says translation of how many units to the right. I know it's going the other way. So basically, I just have to take the two x coordinates that I have, which is 6. So originally it's 6 minus -5. This will become positive. So it makes a shift, or it moves to the right by 11 units. And that would just be the answer. And I could also like literally count, the distance here. It's also a distance of 11. But just to show, having knowledge of vertex form and translations can help you answer. Okay, so now into new content that I think could also be tested in August, which we have, oh my goodness, geometry and trigonometry. So I'm going to go over a couple geometry questions that are advanced that I think could come up, good to know. And then we'll look at a couple trig questions that I also think could come up. So let's go into it and do it. Oh my goodness. So here, point P is the center of the circle in the figure shown, and AB is equal to AC. Okay, so good to know. These equal each other. And it says angle BPC, it's 60 degrees, which they tell us here in the drawing. What is the value of X? Okay, so if you ever get a problem like this, it's important to know that a little bit of a theory. And the theory is the inscribed angle theorem, which just persists. So here, if the center angle here is extending from arc BC, everyone sees that center angle. And I can also see that the inscribed angle, so BAC, it also is being cut from the same arc. So important. And notice what I'm saying, that they're cut from the same arc. So this inscribed angle theorem persists that when you have a center angle provided and the inscribed angle is cut from the same arc, it will always be half that of the center angle. So I know that this angle here, it's going to be 60 divided by 2, which is 30. This is a theorem. It is fact. Okay, but so you might be thinking, but hey, that doesn't give me X. Well, now, though, it makes our life a lot easier to get to X because I can, from here to here, this is the radius. This is also the radius from P to C. I can cut another line through here, and that would also be the radius. And remember, angles are always opposite to their corresponding sides. Since my new line here is the radius, and this is the radius, and this is also the radius, this side correlates to angle X, and this side also must correlate to angle X. How do I know that? Because it's an isosceles triangle. So we see radius, radius, they correspond to the same angles, which are X, and this would be the same. Like the radius of this side corresponds to angle X here, and the radius of this side corresponds to angle X. So I know that 2X, like X plus X here, is equal to 30. So X would be equal to 15. And that would be the answer. And it's really simple to do as long as you know the inscribed angle theorem. Okay, it is considered a difficult problem. Just to show another way in how it's been tested on the exam, could be on yours, who knows? So point P is the center of the circle in the figure shown. What is the value of X? So here I'm given opposite information. Now I should try to find what the center angle is. No problem. So just like I did before, these were the inscribed angles. I can see here too, right, that this is being cut from BC, and this angle here is also being cut from the same arc, BC. So therefore, this would also be 25 degrees, and this would also be 25 degrees. Okay, so this together, BAC, angle BAC, would be 50 degrees. And that is the inscribed angle. And the inscribed angle is half that of the central angle. So therefore, this would be angle X would be 50 times 2, which is 100. And that's the answer. Isn't that so great and amazing? Okay, so continuing our journey. Okay, so this one, you must know inscribed angle theorem very well to do this one. This is really a tough one. A great like final question for SAT exam. Okay, so let us begin. So it says in the circle above, MN has a length of 12. And KL is parallel to MN. Okay. So I know, these two lines, they're parallel to each other. What is the length of minor arc KL? Why is that good? Because with the inscribed, if they're parallel to each other, then I also know that this angle here would be 25 degrees. I have to find KL. I don't have the center angle though. Okay, but not a problem. We can do this. Okay, so here, I want to get basically the center angle here, right? However, I don't have that. But I could get what this angle is, KOM. Okay. How can I do that? Well, let's take a look. So this would be inscribed from KOM, right? Or sorry, this is, well, I'm going from KOM, but this is cut out from arc KM. Okay, I'm also going to keep it in green. Also, this angle here is cut from arc KM. So you see this inscribed angle is cut from the same arc and the same center angle that I created with KOM. So if this is the inscribed angle, the center angle will be double or twice that. So this would be 50 degrees. Okay, likewise, moving to blue, I have arc LN. Arc LN is, if I look from here, angle LMN is it cuts out from arc LN, and I could create another center angle here, which would also extend to arc LN. So since this inscribed angle, 25, is cut out from the same arc LN, this would be 50 degrees, 25 times 2. And then, now I'm almost done. I know here I'm on a straight line, right? So this must be 180 degrees. So therefore, I already have 50 plus 50, 100. So I know for sure KOL is going to be 80 degrees. Amazing, right? And we also established diameter, it's 12, so radius is equal to 6. Why is that important? Because now I have to find the length of minor arc, KL. And to get the length of minor arc, KL, arc comes out from the circumference. So I would apply the formula x over 360 degrees multiplied by 2 pi r. This will tell me what this arc measurement is. Okay, so let's do that. So I have the degrees, right? It's 80 over 360. Can cancel the zeros. This would be times 2. Radius we established was 6, so then this would be 8 over 36 times 12 pi. 12 goes into 36 3 times. So I can see this will simplify to 8/3 pi, which is correct choice B. So that was a tough one, but you see, essentially I have a really good knowledge of the inscribed angle theorem, so it's easy for me to deduce. Okay, so know inscribed angle theorem, and also know this formula here to calculate the length of an arc. It's not given to you in your formula sheet, and you should know it. Okay, so now let's take a little bit of a look at trig. Okay, so trig, I mean, you have to know SOHCAHTOA, and it's also really helpful to know that sine of x is equal to cosine of 90 minus x. This is an identity. So if I'm told like sine of 10 degrees, I know that that would be equal to cosine of 80 degrees and all of these other possibilities. Does hopefully you know these identities, they're important, but let's see how perhaps it could show up. So it says for the triangle shown, which of the equation is not true? Okay, so firstly, let's see what sine is. So sine of x would be opposite over hypotenuse, which would be 42 over 59. Okay, so we can immediately eliminate A because that's true. Continuing our journey. Well, choice B. So remember that sine 90 minus x for trig identities, that's equal to cosine of x. Okay. So cosine of x, let's see, cosine of x would be adjacent over hypotenuse, which would be this value we don't know, but it would be over, so like adjacent over 59. It's not going to be 42, so I think this one is our winner. However, just to go through, cosine, so also remember for trig identities, cosine of 90 minus x, that's the same as sine of x. And we've already identified what sine of x was. It's 42 over 59. So that one is good. So eliminate. And then sine 90 minus x, remember that's cosine of x. So cosine of x minus cosine of x will equal 0 because any number subtracted by itself will be 0. So therefore, this must be B. And if I wanted to define what this is, like a squared plus b squared equals 50, well, c squared, but 42, 42 squared plus b squared is equal to c squared. Sorry, let me write neater. D. So this would be 42 squared plus b squared is equal to 59 squared. Then I could solve on my calculator. Gives like 17. So the square root, it's not a nice clean number. It's like 41 point something or 5 approximately. So I know for sure it's not 42 and therefore incorrect. Okay, so make sure you know your trigonomic identities, especially this one here and this one here. Okay, continuing. Okay, so I did this one in the most missed question from UNSCT, but I just thought I would bring it up here again because, you know, it's possible that they repeat a question from the June exam on your August exam. Okay, so let's go over this one. Point F lies on a unit circle in the XY plane and has a coordinate of 1, 0. Okay, so we'll say it's around here, 1, 0, F. Point G is the center of the circle, and that's 0, 0. And point H lies on the circle and has coordinates -1. Y, where y is constant. Which of the following could be the positive angle of FGH radians? So then I want to find what FGH is. Well, first I should find what y is. That should be easy enough to do because first, using the equation of a circle when centered at 0, 0 is just x squared plus y squared equals r squared. I know what the radius is because this has a radius of 1. So 1 squared. And then here I can put this in for -1 squared and solve for y. So this would just be, right, 1 plus y squared equals 1. Y squared is equal to 0. The square root of 0 is 0. So then I know for 100% certainty that our h value will be at -1, 0, which is here. And I'm asked for the positive measure of angle FGH. So FGH would be this angle here, which is clearly a straight line, so it's 180 degrees. In radians, 180 degrees is pi. And I need to see which one could be, well, could equate basically to 180 degrees. So these look like they're dealing with revolutions of the circle. And remember that 2 pi radians is equal to 360 degrees. So that would make a full rotation of the circle. So if I look at option choice B and I do 50 pi divided by 2 pi, this will give me 25, which means when I do the revolutions, so I make, so I go from here, will be the starting point. This would make 1 revolution, 2 revolutions, all the way until till 25. So 25 revolutions takes me back here. However, I need to put in that extra, I need to get to FGH, which is an extra pi. So this is just 25. It won't take into account this angle here. So, but if I do 50 pi plus pi, this accounts for the extra 180 degrees, so it's got to be 51. Hopefully that makes sense and is amazing to everyone watching this video. Okay, so next up on our agenda that I think everyone should be familiar with are functions. So let's look at a couple of difficult functions. So here I have in the xy plane the graph of linear equation of the form y equals mx plus b and the graph of exponential equation y equals ab to the x power. Both contains points 1, 3, and 2, 4. Okay, if the point rs is on the graph of the linear equation on RT, and the point RT is on the graph of the exponential equation, where 0 is less than r is less than 4, and s is greater than t, which of the following must be true? Okay, well, for this one, I mean, we could find the equations of the equation of the line and the exponential equation, but I think we could also just see this visually. Because imagine it says that they both contain these points. So I have 1, 1, 2, 3, and also 2, 4. So around here. So the line I'll put in green. It goes through these 2 points. So look something, well, it won't be perfect, but something like this, right? Okay, so it's going to through those 2 points. And then if the exponential equation also goes through those 2 points, then it's got to be like something like this. Okay, and then I'm asked if the point RS is on the graph of the linear function and RT is on the graph of the, okay, so they have the same x value, is on the graph of the exponential equation where 0 is less than r is less than 4, and s greater than t, which the following must be true. Okay, so if these 2 points are on, like this is on the linear equation, and this is on the graph of the exponential equation, for that to occur and for them to have the same x value, then it's got to be occurring like somewhere in between this area where they could potentially be touching each other. I didn't draw that greatly, but it looks something like this. And then like imagine you have the x coordinate here. So the x coordinate would have to, let's just say it's around here, could be consistent here, or it could also be perhaps here, etc. And then it would be a little bit higher or lower depending on the equation of the line or the exponential function, but it's going to fall within this range between 1 and 2. So definitely it's looking like option B. Okay, so if you want to be more precise with this, you can deduce the equations, like I can easily find what the equation of the line is, I'll do slope formula. So 4 minus 3 and 2 minus 1. So that would be, the slope is just 1. And then to find the x-intercept, so I have x plus b, then let's put in 3 equals 1 plus b, so I get 2 equals b. So the equation of the line is x plus y-intercept of 2, which actually looks nicely on my graph. And then likewise, I can do that with the exponential equation. So same, I can put 3 is equal to ab to the first power. And then I can also say that 4 is equal to ab squared. I can, let's see. So I can say 3 divided by b is equal to a. Then I can plug this in for our a value. Let's see what happens. So 4 is equal to 3b squared. This will cancel one of the b's. So divide each side by 3. So I get that 4/3 is equal to b. So then if I know 4/3 is b, so let's just go back. So 4 is equal to a. Now I put the b value in, so 4/3 squared. That would be 4 is equal to a 16/9, and then divide each side like by 9/16 to solve for a. So this I can reduce to 4. So basically 9/4 is equal to a. So then final equation of the exponential would be our a value is 9/4. B value, it's 4/3, and then raised to the x. So now I actually have the two equations, and then I can just go ahead and make my life easier and plot it onto Desmos. Okay, so just so we can see visually, I put the exponential function deduce y equals the equation of the line, and then the two coordinates that are supposed to be on the graph. And then we can see basically what I drew with my personal image, that for the coordinates RS and RT, for them to appear or be on parts of both the line and the exponential function, it's got to be occurring in between these 2 points. So it's happening in between this area, just to give a clearer view. But you can answer that how I did initially, just with you know, a little sketch like I did and some knowledge of exponential and linear functions. Okay. Hopefully that made sense and was amazing. Let's look at this one. So f of x is equal to x minus a times x minus b. The function f is defined above, where a and b are integer constants. If f of 1 is greater than 0, f of 4 is less than 0, and f of 7 is greater than 0, what's one possible value of a plus b? Okay, well, first, this is definitely in roots form of a quadratic function. So, okay, so then looking at these, so I know one of the roots would be a, right? And then the other root or x-intercept would be b. Okay, and I'm told that f of 1 is greater than 0, f of 4 is less than 0, and f of 7 is greater than 0. So where f of 1 is greater than 0, it's positive at x equals 1, the function. It's negative at x equals 4. So I could say then that one root, let's say a must be between 1 and 4. So I could say like 1 is less than a is less than 4. And then for the other condition, so I have less than 4 and f of 7 is f of 7 is greater than 0. So then it goes from negative at x equals 4, and then it goes positive to x equals 7. So then I could say that like the other root b must be between 4 and 7. So just, imagine me plotting this, like let's give A the value of 2. Doesn't have to be, which is why they say one possible value. There's multiple possibilities. And then I could say, so we're gonna say A equals 2, and I'm gonna say like B is equal to 5. Okay, so that's one of the x-intercepts. So I'm gonna put that here at 2. And then the other one, 3, 4, 5, the other one here at 5. Okay, so I have my x-intercepts plotted, and I'm just basically asked for what the possibilities of A plus B would be equal to. Well, I mean, one of them could be 2 plus 5, which is 7. It could also be like I could have made A 3 and B is equal to 6. So another possibility could be 3 plus 6, 9. So also important, it does say integer, so I can't put any decimals here. But 7 and 9 could be possible answers. And also 8, I could do like 3 plus 5 as well. Does does that make sense? I hope so. And I hope the x-intercepts make sense because like I know this is a parabola. I know that the parabola is probably looking something like this. Like imagine it's in between these and it goes negative at some point. So it has to go positive, then go back to negative, and then positive again. So it looks something similar to what I'm sketching here on the screen. Okay, and just to show how you could work this on Desmos, so I could type in the original equation provided. Then I put my sliders in the same ranges I gave for B, which was 4 is less than B is less than 7. Um, oop, and then same, well, now I would have to fix that. Okay. And then A1 is less than A is less than 4. It says equal to, but we'll be able to see it just as it is. And then I put the parameters of f of x as being greater than 1, f of x is less than 4, f of x is 7, just to see how this will look when I put the slider on. And when I do that, I can see like this is potentially what it could be within the ranges provided. And also same with A, same thing, which is why there's multiple answers for this choice because there's different possibilities of where the parabola could be shifting. But as long as you get that the x-intercepts do occur between the range, it's got to be between A is greater than 1 but less than 4, and B is greater than 4 and less than 7. So, and that's basically what I was drawing over here. So that could be, the possible values would be 7, 9, and 8. Isn't that amazing? I hope that made sense. So let's continue our journey into exponents. So I made an exponent video about some of the exponents that occurred in the June SAT. A lot of students were like, that's so easy. Nah. Yes, it's true. Like maybe you'll have an easy exponent question on the exam. However, let's try some more difficult ones. Okay, so this one here, two numbers A and B are each greater than 0 and 4 times the square root of A. So always write that out. So 4 times the square root of A is equal to 9 times the cubed root of B. Then I get that A is equal to 2/3. And for what value of X is A of X, A to the X equal to B. Okay, so let's see. First, I could divide each side by 9. So 4/9 square root of A is equal to the cubed root of B. Also note A is equal to 2/3, and that 2/3 times 2/3, right, is equal to 4/9. So I could re-express this over here just as 2/3 times 2/3, also the square root of A. So square root of A, I could say that's the square root of 2/3. And remember, anything under the square root of anything, so it would be 2/3 to the half power. So this would be 2/3 times 2/3 times 2/3 to the half power. And this is all equal to the cubed root of B. So I have the same base, 2/3. And remember, there's an invisible exponent 1 here. So basically, I can now add the exponents, so this would be 1 plus 1 plus 1/2 is equal to the cubed root of b. So 2 plus 1/2 is 5/2, right? 2.5 is equal to the cube root of b. And then, well, I can also make b the same. This is the same as b to the 1/3, just applying laws of exponents. And then I can multiply each side by 3. So this will be cancels and just becomes b. So this would be 2/3, 15/2 is equal to b. And I'm asked for what value of x is a of x equal to b. Well, this is what I have, 2/3 x or 15/2. Wait, 15/2 is equal to b. So my a is the 2/3, b is b. So I know that x is 15/2, and therefore the answer would be just that, 15/2. Okay, so I think, well, I think it's highly probable on August SAT you'll see an exponent problem. Maybe it'll be easy, like the one I showed before in the previous videos. However, it could be more advanced. This would be a more advanced one. Hopefully you loved it and it's amazing. Okay, but let's also look at another one. So here I have 5 to the x minus 5 to the x minus 3 equals 124 times 5 to the y. What is y in terms of x? Okay, so whenever you see problems like this, if you get one like this in August on the SAT, what you want to do is reverse engineer. So I can factor this. I can do 5x minus 3, and this is 5 cubed minus 1 is equal to 124 times 5 to the y. Okay, why am I doing that? Because this, just to show, I know it could be hard to see that this would be 5x minus 3 plus 3. So we see that these would cancel, and this would give me 5x, like the original expression. And then if I distribute it here, this would give me just 5x minus 3, which is exactly what I had, right? 5 to the x minus 5 to the x minus 3. Okay, so hopefully that's clear. So in doing so, that will give me 5x minus 3 is 124. 124 times 5 to the y. I can divide each side by 124 if I want. I will. And then I get that. So 5x minus 3 is equal to 5y. And then I'm asked for y in terms of x. Well, y is equal to x minus 3. And that's the answer. So amazing, right? Okay. And then that's what I mainly think will definitely be tested in August. So rearranging equations, functions, geometry, trig, some exponents. Of course, all the other concepts that you hopefully have done some Blue Book exams and you've seen that the discriminant is on every exam. Vertex form was in this video too. Know your quadratics really well. And as long as you know all that, I think you'll be okay. But I did put some honorable mentions here for those of you who've stuck around for the whole video. So some honorable mentions. I think it's worth noting the density formula. Hopefully you know it from school, but it has come up on the exam sometimes, and they don't always provide the formula, so you would have to know the formula. Example, to study fluctuations in leaf water potential, samples of wood were taken from 24 trees and cut in the shape of a cube. The length of the edge of one of these cubes is 2 centimeters. If this cube has a mass of 3.04 grams, what is the density of this cube in grams per cubic centimeter? So we should know then that density, it is always equal to mass over volume. So make sure you know this formula for the exam. Remember, it's not given to you. They don't always provide it, and you could have a question asking for density. I'm given the mass, right? So mass is 3.04 grams. And I know the length of one of the cubes. I have to put over volume. Okay, so volume is equal to edge cubed. So volume is equal to 2 cubed. So I know the volume is equal to 8. And now I just have to plug that into the formula. So it'd be 3.04 divided by 8, which gives me should be a decimal. And that gives me exactly 0.38. And that's the answer. So I know it's pretty simple question overall, but you should know the formula for density. It does come up, it's not given to you, and also know the volume for a cube, edge cubed. Okay. And then just another honorable mention that I think could also come up, it's statistics. In particular, I mean, you should know mean, median, mode, range, box plots, but also in regards to statistics, sometimes margin of error comes up. And let's just discuss what the margin of error would be in this sample question. So it says, in a study, the heights of 350 randomly selected trees growing in an area in California were measured. The mean height of the trees was 210 feet with an associated margin of error of 6.3 feet. If the study had been conducted with 600 trees randomly selected from the same area of 350 trees, which of the following most likely result due to the increase in sample size? So, I mean, all you really have to know for this question is the fundamental principle behind the margin of error, which is margin of error decreases as the sample size increases. Why? Because we have a larger sample size, and that will give you a more precise estimate of the population parameter, and it reduces the uncertainty of margin of error. So since we've increased the sample size from 350 to 600, the margin of error should decrease because now there's a larger sample size to choose from. So the margin of error would be less than 6.3 feet, would be the correct answer. So just remember that the margin of error decreases as the sample size increases. It's just a concept. It's come up on some of the past digital SATs, and I think it's good to know. Okay. So I just wanted to put those honorable mentions. I hope this video was useful and will help you on your August SAT for those of you taking it. Let me know if you have any questions or if you want me to solve any particular concept or question that you're nervous about. I'm happy to make a video about it and help. And stay tuned because I'll be making the English video of August prediction soon. And just make sure you like and subscribe to the channel so you get those updates. And I hope this was helpful. And that's it. I hope this helps you on the exam. Okay. And oh, also one final thing. Also, watch my other videos of my May SAT predictions and June SAT predictions, just because I think it could be very helpful. Those concepts could also be tested on this August SAT. Okay. Okay. So let me know if you guys have any questions or doubts, and I hope this was helpful. And I'll see you in the next video. All right. Bye, guys.